Hello, this is the CUDAN Open Lab seminar on April 14, 2025. And today it is our greatest pleasure to have Atau Tanaka from Goldsmiths College. And he will talk about human learning times machine learning and machine learning, X machine learning. He'll tell us. Atau, the stage is yours.
Great, okay. Well, thank you very much, Maximilian, for the welcome, and for my friend and colleague, Nuno Correa, for introducing me to the CUDAN Open Lab. Real pleasure to give this talk. So I will share my slides, and then I will no longer see you, but I see a number of people online. I imagine there are people in the room. I will talk for about 45 minutes. I have some sounds to play and some videos to show, and then I'll take some questions. Okay, so let me get the sharing happening. It worked a second ago, so there's no reason why it shouldn't work now. Great, so, okay, so here we are. Yeah, so human learning versus machine learning, embodied AI and music. We'll figure out through the course of the talk what I mean by that. I'm a professor at Goldsmiths, University of London in the Department of Computing, and I also have a visiting affiliation with the Bristol Interaction Group. My social media handles are below. You can figure out which one's which by searching. And so here we go. It's basically a talk about music and AI. It's hard to avoid these days. And most people have an engagement in one way or another with AI, more and more, in fact. So I'll sort of start the talk by telling a story. When I was asked a couple of years ago to give a talk on music and AI for a very general public in Poland. And so I thought, well, this generative AI and visuals were very much the rage back in the time, and still are, in fact. And so I thought I'd start the story with ChatGPT, since everyone seems to have heard of it. And of course, in a group like this, I imagine some of you are using it. We might have some critical perspectives to it, but we know that we can type something in and ChatGPT gives us a text back, usually with some information. So when I was asked to give a talk on music and AI, I thought I would let ChatGPT do the job. And so I simply gave the prompt, write a lecture on music and AI. And this is what ChatGPT gave me. Pretty good. And this is ChatGPT from a couple of years ago. Who knows what it will give me today? It gave me a title, it gave me a structure, and that structure covered history, composition, performance, recommendation, ethics, collaboration. So, I mean, could I have done better? Maybe I could have made my job easy to go to Poland just by reading this. But somehow I didn't feel like doing that because, as it turns out, prior to that, I had written an online text on the history of generative music. This was commissioned by an art gallery in London called Unit London. It's an online exhibition called Sonic Alchemy, exploring the art of generative sound. If you search on those terms, you'll find the exhibition and the essay. I'm happy to share these slides and all the links afterwards as well. So I had already written a text on generative music, so in a sense, I didn't need ChatGPT. So here's the exhibition, and here's the text. Unit London, Generations of Generative Music. This is now 2 years ago. And the text that we see there on the right side of the screen is not ChatGPT, it is my text, okay? So when I thought about human versus machine, okay, my text versus what ChatGPT had to propose, I wondered, well, what is it that ChatGPT really knows about generative music? If it's artificial intelligence, what is ChatGPT's intelligence in this specific area? Well, as it turns out, I've written my text before I gave the prompt to ChatGPT. So in a very narcissistic and self-pumping way, I wondered, well, maybe ChatGPT had been out there scraping the web and found my text. Is it then somehow that my text or the knowledge that I provided the internet somehow appropriated by a generative AI algorithm? Okay. Because after all, any algorithm needs training. Okay. Someone needs to provide what we call the ground truth. Okay. So could it be that ChatGPT fell upon my text and used my own text as a basis for whatever its knowledge is, okay, of this field? Because after all, what the generative model is doing is, if we talk about generative adversarial networks, okay, the generative part starts with random input, really noise, and a generator. And it needs to compare against the ground truth, okay, to see how close the generative proposition is getting to the ground truth. And you've got the discriminator there comparing, okay, the real with the generated, okay, calculating a loss function, and therefore trying to improve the generator. Okay. So somewhere in this, someone had to have text about generative music on the web. I had just written one. I'm not the only one. There are many others. Could I be the source for ChatGPT? Well, so that's the sort of the joke that we begin with. Otherwise, beyond ChatGPT and prompts and generative text, AI has caught the imagination of really broad culture, all the way to the Beatles. So here we slowly start to then connect music with AI. And it was a couple of years ago that Paul McCartney got on the BBC and said, well, we've produced a song, the last song that John Lennon wrote, but we were able to produce it after he passed away using AI. And Paul gave an interview and said, well, we were able to take John's voice and get it pure through this AI. All that kind of thing is scary, but exciting. And I think in that we find a lot of the popular sort of opinions about artificial intelligence. But really, what took place? What does Paul McCartney himself know about AI? What really happened about getting John Lennon's voice back? Essentially, they had found an old cassette, okay, a kind of cassette demo tape that John Lennon had recorded, okay, of a song called Now and Then. And the AI essentially consisted of cleaning up the cassette recording. So in many ways, it's like restoring an old film. Okay? So then the question that begs to be asked is, well, what intelligence really is there in cleaning up a cassette? Right? Is it just noise reduction? Is it something fancier than noise reduction? Okay? Is this active restoration something that we could consider artificial intelligence? Or beyond just restoring signal? Okay? There is this idea that since this is the voice of someone who's now dead, okay, can we resurrect the dead through AI? Okay. Now, the Beatles, when the Beatles do anything, it hits the news, it becomes well known and famous, but they certainly were not the first one. And even in this area of popular music, there had already been an AI duo between a live child and a deceased parent, Nat King Cole and Natalie Cole. Natalie Cole sang with a resuscitated voice, okay, of her deceased father, Nat King Cole. And there have been in Japan, the Japanese broadcasting service NHK that has done a project called AI Hibari, resuscitating a very popular enka singer, Misora Hibari. Now, this kind of thing has received scholarly attention, and here at Goldsmiths, Mui Kato has just a couple months ago defended a thesis called Investigating the Human-Machine Relationship in Contemporary Music Making with AI, Reconceptualizing Liveness Beyond Recording Technology. So we have, on the one hand, this kind of popular press coverage of the applications of AI in this area. A business magazine like Forbes writing about the Beatles, okay? All the way to real serious scholarship, okay? Musicians, musicologists, looking at the creative relationship that we can have with these algorithms. Beyond that, in the cultural sector, AI and music is everywhere. So you have large festivals like the Ars Electronica Festival in Linz, Austria, doing an exhibition on AI and music. And you see the X in there, AI X music. AI, is it AI versus music? Is it AI times music? Okay. But we're playing on these confusions in trying to find titles with hip typography. But for Ars Electronica, for them, the X meant AI meets music. Okay. And we have artists, some of whom very well known, coming out of the computer music sphere, going into popular electronic music. Holly Herndon, who released an album in 2019 called Proto, where she, with her partner Matt Dryhurst, had a baby, an AI musical baby. Okay, and they called it a spawning. Okay? And they birthed an AI baby and recorded an album with this. Okay? So this is now over 5 years ago. Okay, people get excited when a pop musician makes a bold statement like this, and those who are in research kind of scratch our heads and wonder, what really happened? We might want to take a critical perspective to this. And I can imagine you at CUDAN Lab, much like us at Goldsmiths, we're somewhere in between the excitement and the critique. And for a good, interesting artist like Holly Herndon, her own progress in this mirrors that relationship of fascination and critique. So while she may have started with fascination in 2019, birthing an AI baby, suddenly, several years later, 5 years later in 2024, she received Austria's first Digital Human Rights Award. So then you ask yourself, well, has she got a Human Rights Award for birthing an AI baby on an album? And you really ask yourself, well, what's going on? But as it turns out, in those 5 years, her own fascination was tempered. And in fact, she was no longer birthing spawning AI babies and recording albums with them. She became quite concerned with the ethics of AI and the ownership of data sets. So in fact, what she received the Digital Human Rights Award for was some of her work leading up to a recent exhibition in London at the Serpentine Gallery. Okay? I think this is a touring piece. Okay? And it's a piece called The Call, New Rituals for Collaboration with AI. Okay. It was just exhibited a couple months ago at the Serpentine Gallery. There's a photo of it. And in fact, what you see there is a ritualistic, almost religious setting. Okay. It looks like a kind of architecture you might find in a church. But in fact, the drape coming off the top are cables. And the black elements inside, in between the shutters, are computer fans from GPUs. And this is the piece that you see walking into the exhibition. You hear a kind of ethereal melody, and that melody is being generated by the whirring fans of GPUs, of graphics processing units. Okay? The hardware that is needed to calculate and train data sets. And if we go into the exhibition, there are singing voices. Some of you might know the piece, but to summarize it in a couple of words, Matt and Holly toured the UK, okay, to work with 100 choirs across the UK to record their voices, to get their consent, and to constitute a data set. Okay? Not all of the music of Western history, in the way that ChatGPT tries to hoover all the text of the world for its large language model. Here, they were interested in making their own musical model of recordings that they made themselves with musicians they met. And with that, they made an AI choir, okay, that we hear singing. And in the last room in the exhibition, any visitor can go into a recording booth with a microphone, sing some of the songs, and add their voice to the data set. So suddenly, through this idea of thinking about whose data, what we call the data provenance and data ownership, we have artists like Holly Herndon doing ambitious projects, generating their own data sets to create music. Then in the area of prompt-based generative AI, the ChatGPT generates text based on a textual prompt. Okay. Now we've seen in the visual arts systems like DALL-E, which can take a text input and generate something visual. Give me a painting in the style of Monet or Van Gogh. And we've seen all sorts of visual output, okay, that can be very quickly generated by a textual prompt. You can do this with sound as well, and there's a number of systems out there, but there's one in particular called Refusion, okay, that is like ChatGPT for text or DALL-E for image, but you type in a prompt and you generate a sound. And you think, oh, that's really cool. How do they do that? Well, how they do that is that they take existing algorithms for generating image, okay? And by giving a prompt, I would play me some polka music, give me cowboy music crossed with punk music, okay? And it will generate an image, okay? It doesn't generate an image of cowboys and punks. It generates an image of the sonogram of that kind of music, okay? And it smashes them together, okay, to create a generative image for, in this example, of what the sonogram of punk music crossed with cowboy music might sound like. And we can turn that into sound through the inverse FFT. Through an inverse Fourier transform, and we can listen to what that might sound like. But ultimately, it's using the same now what are off-the-shelf technologies of generative AI, in this case, for visuals. Okay. Now, that's okay. Artists are not AI engineers, and there are artists who have gone and made albums with this. There's an artist called Patton, who a couple of years ago put out an album called Mirage FM, claiming for it to be the first album made using Refusion. Now, we don't know what prompts he put in, okay? But the music sounds sort of interesting. It'll be the first sound example I play. And the link there is for the album on Bandcamp. Attention to the number of T's in Patton. Okay. So that was a couple of years ago. And I thought, well, this is interesting. I didn't know who he was. I found out he was in London. I thought he was a musician, producer. Well, he's a conceptual artist. He's doing a PhD at the Royal College of Art, as it turns out. And he's going to be giving a talk next week at Cafe Otto. So I will go to that and I'll get to hear him talk about it. So already in the 2 years since the album came out, The Wire magazine, a London-based magazine on new music, is picking up on this, is having a salon at Cafe Otto, a well-known venue here in London for new music, a salon called In Latent Space, Mapping the Uncanny Valley. Okay. And this is, I think, what Patton is after by generating AI prompt-based sound. It sounds realistic, but not completely. And it's in that uncanny gap between it seems believable, but something is odd. Let's have a quick listen.
Yeah.
sounds like a song. You know, it's almost likable. I picked that track. You know, there are 20 tracks on the album. That's the 19th track. So I've listened to them all, and that's the one I like the best, and that's the one I wanted to play for you. So we deal with it like we would deal with music. We have our own tastes as listeners, okay? And there's something uncanny about it. Sounds pretty good, but sounds a bit odd. And I think that's exactly the aesthetic that he was after in making Mirage FM. Now, the other things that we've seen in this area, and the visuals are the most illustrative, the most, in some ways, well-known, and style transfer is another application area that we've seen, where you might start with an image, okay, apply another style of image, okay, and transfer that style onto the source. And so some of the examples that we see out there on the internet is start with very well-known paintings like the Mona Lisa, okay, but make Mona Lisa in the style of Picasso. So can we do this kind of thing with sound? And the answer is yes. At IRCAM, the well-known Computer Music Research Center at the Centre Pompidou in Paris, some researchers that we know have done neural audio synthesis, essentially a form of style transfer, okay, using a technology called variational autoencoder, okay, but applied to sound. Okay, and so their system RAVE stands for the Real-Time Audio Variational Autoencoder. Let's see what that sounds like. Now, for those of you who work a little bit in this area of interactive music and node-based programming, the software Max might be a tool that you use. Well, as it turns out, the RAVE algorithm is available as a Max object. Okay, you're able to create models of music with certain sound, and transfer the timbre of coming from a model onto music that's being played on a target. So let's see, let's hope now that the YouTube video comes into my computer over the net and out over Zoom to you. Same rhythm. Okay, so that's the idea of style transfer as applied to musical timbre. And I don't want to give a advertising commercial for IRCAM, but I think it's quite interesting technology, and we'll see at the end of the talk why I'm interested in this. Oh, let's see, there we go. Okay, so all of this seems super interesting. Okay. But hold on, it's all also a business, because music, as much as music is an abstract and creative art, the music industry exists as a business. And all these AI technologies have not gone unnoticed for the music industry. So beyond the creative dimension, there is an economic dimension. Okay. And what is the economic interest of generative music? Well, if no human being made it, you don't have to pay copyright to any human being. So generative music is very convenient in that it wouldn't have copyright associated with it. And so ultimately, AI music could just mean cheap music. Okay? And indeed, we've got all sorts of sites now online saying create royalty-free music, use our text prompt music generation system to create music for free. You don't have to be a musician. You can be in the advertising business. And if you don't feel like paying human musicians, these systems are all there for you to exploit or create music without copyright. So in a sense, music AI, we can't say that it's one thing. There's so many things out there. In fact, the first place where AI and information retrieval technologies were used in music were in recommendation engines. So to give us an idea, recommendations of what we might like to listen to. Okay? So music AI applied to listening. And then if we see in the Beatles example, okay, and other more sophisticated examples like now automated mixing, and I don't know if you've seen the last version of Logic, the digital audio workstation, there are automated mastering plugins now. So you don't have to get your record mastered by a human mastering engineer. So music AI for audio production. Obviously, we've been looking at the creative aspects of it, music composition, even songwriting by artists like Patton. But those are still experimental forms. But music AI has been applied to try to analyze pop music, to say, okay, how do we then create a guaranteed hit song? And this is this area called hit song science. So we can see that the text that I wrote about generative music in the contemporary art music tradition is just one corner of the whole landscape of music AI. And in fact, this other corner that I occupy and what the rest of the talk will be focused on is music AI as applied to performance and this idea that I'll introduce of interactive machine learning. And in that, the lower picture, we have a friend and colleague, Mari Kimura, a virtuoso violinist who's working with some of these technologies, performing contemporary violin music with AI technologies. Okay, but first, before we go there, let's take a little critical break and introduce some critical perspectives about the ethics of AI. We might have heard about some of the problems to do with inherent bias, okay? That computer vision algorithms may miss people, human beings, of certain races or cultures. Okay? And so if you look at that photo, you might see what's wrong with the picture. Okay? I've mentioned question of data provenance. Provenance is where does something come from? Where does the data come from? It might be all good and well that we can create these conversational improvisational engines if we've modeled all of, we've got access to some model of all of improvised music. But who put that model together? Where is that data coming from? Who owns that data? These are all very, very important questions. Questions that I hope some of you at CUDAN are grappling with. The most famous example is a data scientist called Kate Crawford and a visual artist called Trevor Paglin, who put together a large image training set called the ImageNet. Now, so there's Paglin and Kate Crawford, and in a kind of tongue-in-cheek way, saying what the computer vision system picked up, how they identified them. Okay? They constituted one of the early large data sets for visual images. Okay? And Trevor Paglin was using it to create his visual art, until one day they encountered this problem of inherent bias. The data wasn't neutral. Okay? And there was, in their work, a kind of ethical dilemma. Say, okay, well, what do? We can't very well just go on creating what looks like cool art if we have a fundamental ethical problem with the data. Okay? And so Kate Crawford has written a book called The Atlas of AI, where she looks at this. Okay? It's a very, very important book now, looking at questions of bias in AI. Okay? The very algorithms that are very, very widespread today in computer vision systems, in the kinds of systems that have seeped into our everyday lives. Another important book, that some of you may have come across is Matteo Pasquinelli's The Eye of the Master, a social history of artificial intelligence. Okay? Pasquinelli is now based in Venice, running a large European Research Council project on the topic. He's a Marxist material historian, okay? And he's turned his eye to the history of artificial intelligence, the social context within which these technologies were made, to analyze artificial intelligence in terms of the labor theory of value. And it's fascinating what he has to propose. So we're going to get to what Pasquinelli says in a moment, but if we back up now to the basics of these technologies, we've heard undoubtedly about neural networks. And the simple illustration that we see of neural networks often is this, okay? It's like this web-like structure, okay? You've got something coming in the left, okay? You've got some middle layer that we call the hidden layer, and then things go out. And there's a transformation of what's coming in to what's going out. And so this is, in fact, a simple neural network consisting of 3 layers: an input layer, a hidden layer, and an output layer. And for us in music, the input might consist of things that characterize performance. That could be live gesture, it could be sound, okay? It could be other media. And because we're doing music, at the output, we want some kind of sound, or some way to help us make sound, a way to control synthesizers, parameters for synths, okay? Or a way to characterize the sound we want to hear, like audio descriptors or audio metadata. So we have several different combinational possibilities of the media modalities of input and output. Okay? And the neural network is a very convenient way to transform one to the other. You could have audio being transformed to other audio. You could have gesture being transformed to synthesizer parameters. You could have visuals being transformed into audio metadata. And if you think of it this way, some of the examples that we've had earlier, even of the more seemingly advanced tools in style transfer, timbre transfer, generative AI, and so forth, can ultimately, in some ways, if we break it down into the building blocks, okay, be reduced at some level to this basic paradigm. And indeed, this is the fundamental building block of all the later AI techniques that come. So with that, we create machine learning. Okay? Machine learning where we constitute a corpus, a data set based on examples of input. Okay? Examples of input associated with examples of output that we would like to hear. Okay? And we train the training sets with them. Within that, we can have supervised machine learning or unsupervised machine learning. Supervised machine learning where we give labels to say what it is are the examples that we're giving them. Or unsupervised machine learning where we'll just give the algorithm a large set of data and just tell it to categorize it on its own terms. Okay? Broad tasks that we like to do with these things are classification, to identify things, okay, based on the labels in the training set, provide labels to new unknown input, okay. Or regression, mapping a certain curve of input to a certain another curve of output. Okay. So in neural networks, the fundamental building block of all machine learning is built on a technique called multi-layer perceptron. Okay? And this is where this is the unit that we see, okay, that consists of an input layer, a hidden layer, and an output layer. So these are some of the basics that you teach in any beginning course, okay, in AI or machine learning in computer science. Seems pretty up to date. Okay. But as it turns out, there's a rich history in this area. Okay. And this history goes back over a half century. Okay. And this is what Pasquinelli covers in his book, The Eye of the Master. So, as it turns out, the idea of the neural network was invented in 1947 by McCulloch and Pitts, okay? Not as a computer algorithm, but as a way to model human visual perception. So on the diagram on the right is a kind of sketch where at the top we have two eyeballs, okay? And of course we know now that the eyes connect to the brain through neurons and that there are electrical impulses that go to the brain. But if we go back to 1947, we have to think about how much of human physiology was known. We knew that the body was electric in some way. But then to think about how perception and sensation, okay, of the visual field coming into the eyes was transmitted to the brain to create what they called a visual field, okay, was still very, very speculative. And this is what they proposed. What it looks like is a series of patch bays or telephone switching network. There's a kind of a matrix there in the middle layer on the left. And a bunch of switches, okay? And in fact, at the time, computing technologies were based on Boolean switches, on, off, and, or, okay? And so the network is in fact a large number of switches, okay? Around the same time, Wiener is coining the idea of cybernetics. Okay? And this has been picked up over the years as the human relationship to technology, okay? Or then the ways that then these interactions fold back on one another. Okay? Now Pasquinelli takes a critical science and historical approach to this to say that indeed there's a biomorphism in this, that computer science that came about after this period was inspired by biology. Because we were starting to think about visual perception in this way, we started to create computers, and neural networks, therefore, is a computer algorithm that's inspired by neurology, supposedly by neuroscience. So that is what Pasquinelli calls a biomorphism. But then he questions that to say, well, but if Wiener was talking about cybernetics, okay, and if McCulloch and Pitts were modeling their proposition of visual perception on something that looked like a telephone switching network. Now, neural networks might not have existed then, but telephones certainly did. And telephone networks were created out of these Boolean patch bay-like connections. So Pasquinelli asks, is there not a technomorphism in the life sciences? Okay? Is it that our understanding or our propositions of neuroscience are somehow inspired by communications theory and information theory that was being developed at that time, just post-war? Okay? And he takes a deep dive into both scientific and social history to spark that debate. And I think it's a very, very interesting thing to think about. Okay, so if we move on, in 1960, Rosenblatt comes up with this thing called the perceptron. And here is the root of our neural network. Okay, well, McCulloch and Pitts were drawing a possible way that the brain might work to process visual input from the eyes. Okay, and it looked like a telephone switching network. Okay, here is an electrical diagram. Okay, so this is 1960, but already we're dealing with sensory inputs. Okay, what he calls association units in the middle, and response units, outputs. So we really have here the input layer, the middle layer, and the output layer already in 1960. But he's thinking about input, hidden layer, and output in terms of visual perception. Okay? So what we see on the left is no longer an eyeball, but it is a kind of a matrix, but that he calls a retina and retinal unit circuits. So this is some kind of bio-inspired electronic circuit. Going to the switching network of hidden layers, and finally outputting to the right in output layer. And this is what he calls the organization of his Mark I perceptron. A couple years later, he files a patent. So these things have commercial interest. And here we start to really see the diagram much in the way, okay, that we know it today. Okay, there are a number of input layers. There's a hidden layer and there's an output layer. Okay, and somewhere in the lines that connect one layer to the other, we have this notion of weights. If you see that word weight, plus minus one there in that top line. Okay, this is really the foundations, okay, of neural network technology. Again, invented and patented over 50 years ago and still used today. So the social context of this isn't just, is it bio-inspired, okay, is it biomorphism, or is in fact life science technomorphism? The social context in this is a lot of this research was military funded. And so if Rosenblatt is interested in a retina, okay, he's creating early computer vision systems. Okay? And what were these computer vision systems commissioned to do? They were commissioned to classify possible targets, to identify warships, okay, against a grainy background of the ocean, okay, or of trenches and other airfield structures on an aerial photograph over ground. Okay? And this was the first application for the multi-layer perceptron. And so through what seemed to us very low-tech but somehow familiar, okay, workflow, you have visual input coming into the digital system being represented by a series of pixels, okay, converted into dots, and then if the visual field becomes mixed with noise, it's a question to see whether we can still recognize the object that we're after, whether it's a ship, okay, or an airplane inside a compartment. And if you look, I don't know if you can read the figure captions, but this was using very, very low, like 20 pixel by 20 pixel, okay, sensors. But see here in our 50-year history, that drawing that I gave you as that sort of beginner's class on neural networks, in fact, is the same drawing as Rosenblatt had, okay, in 1960. And so what he conceived and invented and implemented then for the military as a functioning computer vision system, okay, to identify warships, the multi-layer perceptron is the same multi-layer perceptron that is at the core of the machine learning algorithms we use for our creative work. And that has been implemented in end-user applications by colleagues like Rebecca Fiebrink in her Wekinator software, okay, exactly 50 years after Rosenblatt's multi-layer perceptron. And some of those very technologies that we've taken as libraries with Mike Zabinski to create a max object called RapidLib a few years later. And these are the technologies that I use in performance. So all this has taken already 45 minutes. So I'm going to just race through this bit because I'm speaking to a fairly specialized group, so you might not need the beginner's lesson on AI. But if we just review for a few seconds the basic steps of building a corpus, okay, a training set, a data set, by recording, in this case, X and Y pairs, input-output pairs, okay? Then the role of classification is to take that data set and to draw a hyperplane, okay, separating that data space into categories so that when we have a new, so you have in this case 2 classes, and so then if a new unknown point comes in, we can classify it as being of one class or another. Regression, the other task, is the same. If we create our data set, instead of a hyperplane that separates classes, we're going to calculate a regression function, a linear regression function that is the most reasonable line through that data. And this allows us then to take a new unknown input coming in on the x-axis and say, well, what might that output be? And of course, if it's a straight line, it just seems like interpolation. But in an interactive machine learning workflow, we're able to create the training set through recording, train the model, run the model, okay, but then evaluate it. Say, well, are we happy with what we see? And if we're not happy, we don't have to start from 0. We can edit the training set by adding information, taking away information. So if we go back to our simple regression model and say, well, that straight line is a little bit boring, we can say, okay, let's go back, but let's not go back to the drawing board. Let's keep our training set, and let's try to make a more interesting training set. So we'll add a point, a new point, and train it again. And lo and behold, we get a more interesting regression function. We like that, and we say, let's keep going. Interactive machine learning. We take that away, we add another data point, okay, and we train again. And suddenly, we don't like what we see anymore because we've got overfitting. Suddenly, the new input, the green coming in on the X, could now be confused as any one of 3 different outputs going on the left. Okay. So we say, oh goodness, we've gone too far. So we can delete that last data point because it was too much for the system, train again, and get back to the regression model that we liked. So there, in a nutshell, is the interactive machine learning workflow. So that's what I use in a performance project called Human Learning versus Machine Learning. Okay? If in this talk until now, we've seen that text prompts can generate music, that we can do style transfer to transfer timbres from one to another, or that artists out there have been spawning models of voices or creating work to prevent it. I'm interested in my work in seeing where is the performer, where is the body of the performer. And if we're to work with machine learning algorithms, how can I do that in a live performance context? So we can model instrumental gesture. A machine can learn the human learning the instrument. Okay. And we can do that with computer vision systems, motion capture, for instance, etc. But because I'm interested in the human body, I'm going to take a slightly more complex signal than a camera signal. And so I work with physiological sensing, okay, that captures muscle tension using a signal called the electromyogram. And often what I do in the performance, machine learning or not, is to map performance gesture to synthesize sound. But in this case, I'd like to use a neural network. I'd like to use a neural network to help me map body gesture to sound output. So the muscle is our input. Audio is our output. And in between, we've got a neural network creating a regression model. And here's the tool set that I use. I'm a specialist of muscle interaction, so I've got a number of electromyogram tools that have been published on a GitLab repo. Okay. And so if you're interested, you can check those out. Okay. At the sound output, I'm working with Earcam's cat art technology. This is not rave yet, but this is a concatenative synthesis system that was created by Dimo Schwartz at IRCAM that creates an information space of sound grains based on audio metadata. So those green and red and blue dots that you see, okay, are sounds coming from that longer recording that you see in the red, okay, that have been segmented and analyzed for descriptors, audio metadata, okay, and in an unsupervised way been mapped into a feature space so that sound grains are being clustered based on their similarity, okay, based on their similarity in any number of 18 metadata features. And that list of metadata features is what you see in the middle panel of the max patch below. Things like duration, frequency, mean, energy, periodicity, loudness, centroid, etc. This is unsupervised. We wouldn't give a slice, edit a bit of audio and say, well, here's the centroid that I like. You know, this is an example of unsupervised analysis. It's gone and done a feature looking, analyzing every grain that's produced in an audio segment and looking at these audio features and then creating a distribution of that data set, okay, and a clustering of that data set based on similarity. Okay. So we've got that sort of analyzed audio data set on one side that I would like to play with muscle input coming in. Okay. So muscle in, sound out. And what we've got are audio metadata to drive what sound is played, and electromyogram, muscle tension, as the input. And so I'm able to do a feature extraction on the muscle tension. And that's the sort of the multi-slider that you see on the left panel, EMG 1 through 8, the sum, the combined, the quaternions of a motion sensor. So I've got features, okay, that describe my musical performance gesture, and I've got audio metadata that describe the sound in my sound corpus, and I'm going to train a neural network to associate, okay, gestural input and sound output. And I'll use a neural network based on multi-layer perceptrons to do that. There's a Max object called Rapid Max that was created by Mike Zabinski and some of our students here at Goldsmiths. And a collaborator of ours, Francesco DiMaggio, has created the help files for that, and that's available there on his GitHub. So that's the system. And with that, I create a piece where I start on stage with an empty data set, a kind of a tabula rasa. Okay? So we're not dealing with big data. Okay? And if we think about whose data, the data ethics, and so forth, this is my data. It's a personal data set. But in fact, when I walk on stage, there's no data. Okay? I will constitute the whole data set as part of the performance. So it will be a tiny data set, small data set. It's this thing that we might call tiny machine learning. Okay? And I'll actually perform the data set. I'll record the body and sound input-output pairs. I will constitute the data set as part of the performance scenography so that the audience sees that process of building up a data set. Rather than going on stage and saying, here's a piece of AI music. I've created this piece by using AI. I mean, how are you to know? Right? So a lot of AI art we're asked to take on face value. In this case, I'm interested in revealing the process of data recording, training, and running. Okay? And by doing this, body muscle tension is mapped to a corpus of audio data, and in the excerpt we're about to hear, it's in fact a chamber orchestra piece that I had written a number of years ago that I use as a corpus. So this music is my own, the body data is my own, but the association and the performance between gesture to output is new and live and takes place on stage in concert. Here's a little video. Okay, I'll leave it there. But that video performance is online on YouTube, and I'll provide the link later. But what you hear are grains of orchestra sounds, and they're sort of familiar. We hear strings, flutes, etc. And they seem to be evoked by this free space gesture. It's almost like I'm a virtual orchestra conductor. And if you listen through to the piece towards the end, the complexity of the music builds up. It starts rather simple with one sound, and by the time where I stopped, we're still in the first couple of minutes of the piece, but we've already started to get about a handful of different sounds that I'm able to find in the 3D space, in my gestural language, to be able to reproduce those sounds, but that aren't completely the same every time. And so somewhere in between the sounds that I've trained to gesture, I'm able to find new unknown sounds that are nonetheless in a similar timbral space. So what you might not have seen is the process of capturing and recording. I'm doing that discreetly by pressing on a foot pedal that's on the floor, okay? That gets me through as if I'm turning the pages of a score instead of turning the pages of a notated musical score. Here the foot pedal is capturing the muscle data and the sound data at different moments in time to constitute the data set. Okay? It's a data set through the interactive machine learning workflow that builds up. I continue to add points that associate gesture and sound to this data set. And at different steps along the way, the click on the pedal on the floor will actually train the neural network and run it. And those are the moments I get into a kind of interpolative space. So with that explanation, I'm going to play a couple more minutes. Okay, so I'll leave it there, but that's a short excerpt of a piece called De-Learn. Okay, so I had mentioned the Rave variational autoencoder. That's what's next. So yeah, De-Learn is starting to get to be an old piece. Some of the Wekinator rapid lib technology we've had around for a few years. But old isn't the question here, is it? If we're talking about a history of multi-layer perceptron that goes back a half century. But nonetheless, the combinations in which we use these technologies become interesting. And so just to give a little bit of a preview of what's next, I've got a commission for next year from a French group called Artzoid Studios, working with a percussion ensemble in Geneva called Eclecto, where I will be writing a new work for a trio of percussionists and a generative rhythm system. So I'm interested here in putting the muscle sensing on percussion players, okay, picking up then their gestures, constituting an audio corpus of recordings of their instrumental performance, and creating a rave model of that. All that will take place offline, because some of these training models as procedure is enormously time consuming. There's an offline activity, but once the model is created, it can be played live in concert. So all that's being conceptualized now, and is the piece that I'll be working on for next year. So to summarize, human learning versus machine learning. Well, then backing up, it's all to say, I think we all agree, AI is not magic. Okay. It can, though, surprise us. It can be very practical and might be able to help us, but we have to be careful, it can hurt us. Okay. But as artists in these domains, regardless of what it is, it's got to be interesting as music. So we need to start with a musical idea. AI is not going to provide something that's not there. We bring a musical knowledge to the situation. We bring a musical culture to the situation. For after all, AI by itself has no agency. It has no inspiration, no creativity of its own. But it does have a social history that has conditioned the way in which it's been created. And if some of that history is coming out of a post-war, a cybernetic, behavioralist, military-driven point of view, it's something we need to critically examine. Okay. AI only knows what we tell it and how we train it. And so for the machine to learn music, the human must learn music as well. And so that's it. Thank you very much.
Amazing. Thank you very much. I can already, okay, so this is claps. Silent claps because people are distributed. Thank you very much. This was excellent. I have many questions, but I think I would like to enable the audience to ask questions first. So anybody questions in the audience?
Yes, I am from Chile. I am a media artist. I am researching in a textile touch with data. I am interested in a politic of touch as a performance with generative sounds. When I touch this device, this soft textile, with external data. It's made possible to work of this in the same times with light, for example, light data of a place of performance, all with sounds. I am searching to learn generative sounds or eye sounds.
Okay.
This. Yeah.
Well, thank you. And so is there something in what you saw in the presentation today that you think could be relevant for your work with textiles?
Why I work with textile?
Well, I'm interested to see if there was a question that you had, because in fact, it's very interesting that you mentioned textiles, because this is the other new area that I'm working in. On the talk that I just gave on Saturday, if I can, I don't mean to give two presentations, but let me just quickly share screen. This might be of interest to you. Let's see, let's share this one. Yeah, you're interested in touch. And so I've got, my new project is called the Technologies of Touch. It's a project that's just started. It's going to run for 3 years, funded by the AHRC, the Arts and Humanities Research Council in the UK, and the Deutsche Forschungsgemeinschaft, DFG, in Germany, that puts then Goldsmiths in collaboration with the University of the Arts in Berlin. And so my collaborators are Berit Granke and Ariana Yasula, and we're really looking at this question of touch through my muscle performance, interactive textiles in musical performance. So here we are going to look at questions of touch. We've each got previous projects. In my case, working with signals from the body. In Berit's case, creating these interactive garments for musicians. Yeah.
Interesting is that the second image, but it's the ¿cómo se dice? Part of cloth, part of textiles, participates with an instrument.
Yes, that's right. That's right. So this is a previous project that she had. Well, we've just started this new project. We will then combine the body signal as well as the electronic textile signal. And so we're interested then here to look at the histories, cultures, and ethics of touch. And I think this is what you were mentioning in your question. And to create then body technologies using the muscle sensing, and also garments using electronic textiles. So we'll see where all this goes, but this is a new project that is just getting started. Yeah, and so we're interested in being touched and touching. That is active and passive. I'm interested in these questions of proprioception, the awareness of touch. Yeah.
Yes, interesting. Thank you.
Thank you very much. Mark Hannett has a question.
Hello, thank you for the presentation. I really enjoy it. Yeah, I'm from CUDAN. I do practice-based PhD in fucking strategies of artists using artificial intelligence. I didn't know your project about this, that you make a training set on the stage. I'm really interested on this. I mean, in fact, I am very interested in small data sets and open small models in general, because I think that is the fundamental part for artists, especially like you show, like if you do some kind of art project, some project, interactive. I do a lot of interactive art, more in visual, but like you cannot rely on closed models, especially because they can disappear, they can close, and also because the processes that we work in general are long. Like you said, you're gonna work now 4 years in touch. Like every 6 months they disappear one model.
Yes.
In I don't know, in OpenAI ecosystem, let's say like this, but also in Google ecosystem or any other ecosystem, and also some of the processes that we do require much more control over the algorithms and the weight and the latent space navigation and so on. But the question is maybe on this tabula rasa, are you then training on real time because it's very small model? Are you training real time in the stage?
Yes.
That's what I understood, right? And which you said you're using. Sorry, if you have somewhere written, I will delighted to read and include in my thesis in actually.
Okay.
But how is the architecture that you use?
Yeah, so that's this slide here. And so if you take a screen capture of this and type in the...
I took already, yeah, thank you.
So the Rapid Max is where the neural network is, and indeed it's small data sets. So we're working with very, very small number of examples.
Okay, how many, just to get some info from you, how many samples at the end at the end of the performance you think you have, more or less?
Yeah.
About hundreds or...
So let's start with first the audio corpus, okay?
Yeah.
So the audio corpus, what you see here in the red, is the source sound. And that was an orchestra piece that I had recorded. It's a 12-minute piece, okay? It's a 12-minute piece that has been automatically segmented. And so the red there is supposed to be, there are supposed to be lines actually. So if you zoom in to that audio waveform, you'll see audio segments, you know, the red line creating separation between different moments. That's been automatically generated based on different audio qualities, whether it's a transient attack or so forth. When it's zoomed out, all the lines pile together. It just looks like a red background. But that 12 minutes of music is segmented into small grains that can vary in length from anywhere under 100 milliseconds up to a second or more. So there are tens of thousands of grains that are then constituting the audio corpus and then that are mapped into the information space. Now, that's being done by cat art. And now, the way that cat art is often presented is visually like this. You see a scatter plot, okay, X, Y on a Cartesian plane with color giving us a kind of a third dimension. And so you can play the cluster, audio clusters by mousing over the data set. But it's a little unfortunate because then you're only playing in a two-dimensional plane an audio corpus that's been analyzed in 18 dimensions. It's an 18-dimension feature space, okay? That if you're using the computer trackpad, you're only playing through 2 dimensions. So that seems kind of poor. And so what I'm proposing is to, instead of exploring that audio corpus with the computer mouse, to explore it using muscle tension. Okay? And so you saw me waving my arms around in the video. I have 4 channels of EMG on each arm. And so these are the 8 lines of that look like an oscilloscope reading. That's the muscle tension coming in, okay? 4 from the left arm, 4 from the right arm. It's a very complex signal. It's a real-time time series, and we can do feature extraction on this. And so we get 19 dimensions of gesture analysis at the input. Okay, so that's the dimensionality. Okay. And I thought that by having 19 gestural dimensions at input, it would allow me to explore this audio corpus in a much more interesting way than XY with a mouse on this colorful scatter plot, if you see what I mean. But if we want to do an 8, and it's just almost coincidence that the number of dimensions on the input, 19, and the number of dimensions on the output, 18, are almost similar. You know, I mean, I could have, 12 dimensions in and, 20 dimensions out. But whatever the case, it's too many dimensions of information for us to work with in a traditional mapping approach, to say, okay, I'm going to take the tension of this muscle and map it to the grain size of the sound. If we're to try to take this many dimensions of input and make a manual hardwired mapping to the sound synthesis parameters, it's a bit laborious and it's hard to say whether it would be meaningful or not. Okay, so we have a kind of a mapping problem. Okay, and this is the motivator to call in then a neural network. Because if I was just to say, oh, let's take the power in the left arm and control the synthesizer's filter cutoff frequency. You don't need AI to do that. Then you just take, and we do this often with sensing, physical computing, etc., is to create a mapping of one modality, one sensing modality to an output modality. But if you have this many dimensions, we're starting to get to a dimensional space that hand mapping is inconvenient. We create then actual need for some technique like machine learning. And that's important for me to state, is that, this is filling a need, something that we couldn't better do by hand. And so what we're creating then is a mapping between gesture and sound, okay, but not directly from gesture to sound. Each medium, the input medium and the output medium, have been analyzed, and we've done feature extraction on them. So we're mapping from a gesture feature space to an audio metadata space, okay? And we're mapping 19 dimensions of muscle feature to 18 dimensions of audio feature. And that mapping is then being facilitated by the neural network. Now, when I record,
an autoencoder,
no, it's just a multi-layer perceptron. It's a simple, like the example I gave, right? And so when I'm on stage, I will, if you rewatch the video and I do a short explanation, you'll see that the sound is quite static at some points. It just sort of is repetitive, And what it's doing in the composition, I've identified certain what I call anchor points through the piece that are the reference points in the sound that I like. And so if we start, that is a sound that I've chosen compositionally. And in performance, I'm going to find a position of my body to associate with that sound. And then I'm going to sort of stand there and hold that position and then click on the pedal on the floor to capture that moment. Okay, that's the beginning of the training set. Okay, and so then you could say, oh, here's this position in XY space and muscle tension connected to this sound. Boom, 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 boom. However, it's not that simple, okay, because there are 18 dimensions of that sound and 19 dimensions of this gesture. Plus, the human body doesn't stand still. So I'm not taking one data point here. As I'm standing there and I click the pedal on the floor, I'm trying to hold my muscle tension. It's a live signal. It's jumping up and down.
There's a bit of noise.
Window of time, yeah. I capture a window of time that might be 50 samples of muscle, of gestural data, okay, that are associated with this set of audio metadata. And so one point in my data space is at least 50 samples of 19 dimensions of electromyogram and position data. Okay. And I'll do this, then the piece builds up. Compositionally, there are only about 6 points in the piece. The whole piece lasts about 10 minutes. And every minute or two, I'll then move to another position. You'll hear another sort of stuttering sound, and I'll capture that association of gesture and sound. And then after the first two, I'll train the data set, and I've got a simple interpolation between those 2 points of about 100 points. And then I go back to recording more points in the data space, and then I keep adding to it. And by the end, I've got therefore about 5-6 postures associated with 5-6 reference anchor point sounds, each of which has about 50 samples. Okay, so you can do the maths. It's a tiny data set, but it's it's in the hundreds, okay, of data points, but with many dimensions of data. And that's what we train the neural network on. And it's small enough data that then I click the pedal again and the training takes place. The max patch sort of freezes momentarily, but since musically the piece is based on stuttering and then smooth, stuttering and then smooth, we don't mind that it hiccups while the neural network is training, and then suddenly it runs, and then we're into the, I think you heard something goes like, a car taking off, and I can shape the sound, and suddenly I'm moving fluidly through space. So
Really interesting, because I had done also in my artworks, on the practice base means I had done in the artworks these kind of things that the AI takes a moment sometimes to do some things, like you say, the training, and you incorporate it inside. That's I also did in my work, and this is very interesting because that's how we, if you want to do interactive AI, which also do, is necessary. Otherwise you.
well, it's not necessary, but I think it's part of the interest
Yeah,
of
it's very interesting.
for
Yeah,
us.
but
And I think it should be of interest then to the audience. It may be interesting for them. It might demystify the process for them. But indeed, yeah. Sure.
thank you very much.
Question from Patrick.
Thank you. So and the next question would be Nuno Correa, who's in the room here, and then Patrick.
Okay.
Hi. Thank you so much, Atau, for the really insightful presentation. Thanks for CUDAN for organizing this. Atau, so just to, also my question is a little bit biased because I'm interested in movement and
Yes.
pressure as well. So, and you asked the question, where is the body? And the answer goes a lot towards the mapping, right? In your work, in the work you presented. So I wonder if you've considered kind of modeling, going another way in this answer to this question, and kind of model the body, because you're collecting, okay, it's tiny data, and but if you add up all your performances and all this kind of tiny data together, you get a lot of, you could have a model of Atau's muscle somehow, and actually have like a simulation of how Atau's muscles react to this piece of music or to that piece of music. Is it something you've considered, or?
Yeah, absolutely. No, it's a good suggestion and something I've been thinking about over time. So this would connect to an area of interaction research that you have called activity detection, right? And back in the days when I worked in Newcastle at Culture Lab, we had some colleagues doing HCI research in a smart home. Back in the day, this kind of research in a smart kitchen. And so we would try to detect activity like, are we chopping vegetables, or are we pouring a cup of tea, etc. And they did that using very simple accelerometer sensors. But so there we need a kind of data set. It's almost like making a self-driving car. You need to map, and we know the problems today of the self-driving car. It's very difficult to generalize. And so somewhere in between, sort of this generalizing of human activity detection and this sort of very personal musical creativity in production, I think there is some kind of modeling of the body that can be done, and something I've been thinking about, but it would entail something similar. And this is something I will do in the new percussion piece, is to, and something I got used to with the piece I did last year for the Ars Musica Festival with the Erama Trio. I got to, in making a new piece, rather than just writing the piece as a composer and then going to the musicians and saying, here's the piece I've been commissioned to do, you perform it. I like to work iteratively, interactively. And so in these work with musicians, I organize a number of different sessions. We'll record, take samples, and indeed, in the new one, I'm interested in recording muscle tension data of the performers doing different tasks, and starting to constitute a corpus of corporal data. That's what it would take. For myself, if to answer your question, could we get an Atau model? Yeah, I could. And I could, if it's myself, I could imagine wearing muscle sensors around all day, every day, and just sort of recording, No, and I have thought about this. And then you think about, okay, what would it take to analyze the data? And if it's for music, what would it take to filter out all the data that's not relevant? And so these, you very quickly you get to the practical issues. And then the machine learning scientists would say, well, don't worry about what's not relevant. The algorithm will take care of itself. And that's where, I might believe it and I might not. And that's where there's some interesting investigation to be done. But for you working with dance, for myself, in music, rather than just wearing the sensors all day, every day, I can focus on rehearsals. I can then create tasks. And so then this takes that sort of unsupervised space to say, let the algorithm cluster it, and it'll just filter out the outliers, rather than trust the algorithm to do that with all its potential biases. If we as creative practitioners can help supervise the situation, then we might have a more meaningful corpus of body data to start with. And that's really something of interest. There are certain data sets out there that capture human activity data. To do this for things like dance and for music could be super interesting, and to make that data available as open repositories could be really, really interesting. But the conditions in which they're recorded need to be, we need to take care, and then, but the algorithms can be pretty good about invariance. And so, if electrode placement is in a different place on different days, the quality of the data you get might be different. But very quickly we're able to start to deal with invariance in a way where the algorithm can help us map across inconsistency in data capture to still get to the information inside. And I think these are all the issues and topics that we might want to think about in this regard.
Public.
Hi, Atau. Actually, my first question were asked already by Nuno. So, so I will. But
you get an extra one.
Sorry.
You get an extra one then.
Yeah. So basically, it's a very similar to what I would like to do at the moment, Atau and Nuno. So we try to model a specific gesture based on the dance movement, and just quite a bit of hint from what we are doing. Instead of using Max MSP, we're actually doing Touch Designer. And there is a specific feature there, which is time-based, that actually will be helping us to do it in real time. I mean, we can talk further about this later. But my last question is about how you want to work with Rave. Because, of course, Rave, mostly we're working with the data set in order to training the models, right? But is there any specific interactivity that you think you can do with Rave? Because I don't think there's no much.
Yeah. So this is a question about how this new project will go forward and what the limitations are. And so, so right away, there's a fundamental inconsistency in what I'm claiming to do in the new piece, right? Because I said somehow I'm interested here in the new work to move from the mapping problem of gesture to sound to some kind of generative. And then, so maybe I'm just following the trend of generative AI. But because I'm working with percussion ensemble, I'm interested in a generative rhythm. Okay? Now, Rave does not do generative rhythm. It does a kind of style transfer of timbre. But what I'm thinking of doing, and we'll explore the possibilities of this, we'll host one of the developers of Rave at Goldsmiths in June, really to find out what's possible. But I'm thinking if I record a number of different rhythms, constitute a Rave model based on percussive playing of different instruments of different rhythms, if it becomes a multimodal data set that also has the gestural input, to start to see what we've got in the data set, how we might segment the data coming in, and how we might reconstitute it, not with one technique, not with one algorithm like Rave. Rave can take care of the timbre in an interesting way, but it's not going to model the temporal nature of the rhythm. And so I'm thinking about how to do that now. And so in the end, it might be that I use the old system of mapping, alongside Rave. It might be that I draw upon some of the temporal modeling with hidden Markov models and so forth. But I don't want to say too much. It's completely speculative. These are indeed the questions that I'm working with. And in some of the things, well, Patrick is a colleague at Goldsmiths. We've been in a discussion group about music and AI, and as part of that, we've invited one of the Rave developers to come in. So we'll be able to ask this very question to him. But that's very much the sort of process of exploration that I'm interested in now. Yeah. But the musical goal is there. Why rave? Well, I've done a sort of initial kind of research in the rhythmic work, and the trouble with there are variational autoencoders for rhythm, actually, and a former postdoc of mine, Nao Tokui, in Tokyo, has got a very interesting system, and he's got a company that produces some interesting software tools, and I'll put his name in the chat. And he's got a variational autoencoder for rhythm, but it's for MIDI rhythm, and so anything to do with we've got a colleague, Matthew E. King, that's produced conversational improvisation systems, similar to Francois Pachet's Continuator. These all work with MIDI. And so in order to get a hidden Markov model or variational autoencoder to work with time series, we're dealing with music in a symbolic domain. I'm interested to work directly in the signal domain, but in order to bridge the signal domain and the symbolic domain, we might need to get to some kind of level of segmentation and labeling of segmentation. So I'm sort of thinking aloud now. But in both Nuno's question and Patrick, in your question, you're asking me literally the things that I'm thinking of right now in my own head. And this talk is my first chance to sort of explain these things in a group.
Thank you, Atau.
Thank you very much. I got a sort of series of questions, which I'd like to sort of first emphasize the kind of thing. We do this lecture series asking people from the community to suggest people, and I have been a little hesitant with my personal pet interest in electronic music to come out of the closet and invite somebody, but you touched on so many things that in the last 9 years, I have spent basically all my sort of spare time, as they say. And one of the interesting things is that you gave an answer to a lot of questions which people have when they work with electronic musical instruments, which is like, how do you bring in the human factor, which is like one of your major contributions here. And so one of the interesting things is that you sort of, instead of having sort of noise, the oscillator or the timbre of the instrument, you are the source of uncertainty, which is sort of the most crazy aspect of your work. So speaking about this, when you do what they call patch from scratch, like when you go on stage, all the cables are plugged out and you start plugging in, that doesn't work all the time. So my first question is, what can go wrong, and how do you train yourself to get over these situations?
No, that's a good question. And it's an important one. It's this question of taking a risk, and the danger. And I think music would not be exciting if there was not danger. But the more technological we become with music, in fact, digital technologies, in some ways, we liked digital synthesizers back in the 80s because the analog synthesizers we had back in the day didn't have memory, or the oscillators took time to warm up and weren't necessarily in tune, Of course, analog electronics has become a lot better since then. Better, well, it's an interesting question, but what the digital offered was a kind of reliability in reproducibility. Right? Could be the same every time, and in some sense, musically, that interests us. But then if it becomes too safely the same every time, it stops becoming interesting. Right? And so, but music is this, isn't it? It's somehow, whether it's composed music or improvised music, it is this balance between something recognizable and something new, something that's the same and something that's unheard. You can, even if it's completely composed note for note, you can play a Mozart sonata, you know the piece, but it can be played differently by a different pianist, or you can play it differently depending on the energy in the concert hall or the acoustic of a new concert hall as opposed to the previous one. And so there's always some element of unknown that we would like to bring to bear. So somehow I'm interested in this dynamic in music. I'm interested in the possibility of the thing breaking down, of the thing blowing up. And we're too often safeguarded against that with digital systems, because digital distortion is not very pretty. We like analog distortion, and then with analog, you can really push it. And somehow there's this sort of intense energy before the amplifier blows up. Digital distortion is not that interesting, but still, I'd like to get to that point of a kind of energetic breaking point in these technologies, not to break the technology in a destructive way, but to reach that limit point, and to find the negotiation, the musical negotiation at that breaking point. Now, whether it's live coding or patch from scratch or what I call a tabula rasa, yes, you can push this to the extreme, or no input mixing board, to say, nothing can become something, And of course, there's an extreme risk in that case. But I think if you see most live coders, they've got their sort of favorite palette of subroutines that they can copy paste quickly to get something. The no input mixing people know their mixing board. They don't do it on any mixing board because they know what sounds, what leads that they can short circuit to get some sounds. And modular synthesis who patch from scratch probably have a memory, of how to start, maybe even a composition in their mind. So there is structure even in this seeming blankness, and I certainly do in the tabula rasa. I am a composer. I have composed a piece. I know those anchor points, the reference points in the music. I can change the gesture that I associate with it each time, but I want to find a posture of the body that I can associate with that sound, that I linked musically to that sound, so that in performing the piece a number of times, I get even in the openness of improvisation a certain language that is that piece. But then it's up to me to push that, to try something new, to maybe try something I hadn't before, to push it to a danger point. And that's the risk, that I think is the life in music.
Then there is this sort of an inversion of the last question. So I recently had the extreme luck sitting at the centennial of Schoenberg's death, right beside three violinists playing a piece. And I was blown away by the variety of sounds. One of them was getting out of this violin, like from triggers to super long arches and timbres that I never heard out of a violin, or was never attentive to. And in some sense, what you're doing is you sort of use your muscle recordings as sort of control voltage. And you can see these moments when you do a gesture and the sound seems to be perfectly in resonance. But one of the questions is like, obviously, we got like 350 years going with violins. Is there something where you have to work around the shortcomings of that sort of recording process, or do you think that, like in other words, is there, how much innovation can we can we sort of like expect from these kind of systems, or are we essentially there in this kind of stuff?
Well, how much can we expect is only how much we ask. You know, I don't think we ask enough. We're too content with what we have, perhaps. And in some ways we should be, because we don't use what we have enough. You know, so it's a kind of another these double-edged swords. But if we go back to the violin example, well, many of us got into electronic music by saying, I want to make a sound that's never been heard before. I want to go beyond the limits of acoustic instruments. And electronic music provides me a possibility of new sounds. But then the minute you go on stage with improvisers, and I've got a digital electronic system, and you have these acoustic instrumentalists who are so quickly able to completely change their tonal palette and timbre and articulation, and then you're stuck there trying to reprogram your synth, or, you know, the adaptability that we have with technological systems on the spot in a spontaneous situation is actually much less, I think, than acoustic instrumentalists have. And if you describe what you heard of these three Schoenberg violinists, I think we share that amazement somehow with what an accomplished acoustic instrumentalist can do. And so I'm always looking for that level of flexibility, that level of spontaneity, and as a pianist and trained instrumentalist myself, the gold standard is to try to get to that level of being able to speak with the instrument, but with all the electronics. And it's not an easy one. And so in that case, for the innovations, we should be content with what we have and try to go deeper into how fluid we can be with what we have already. Or the other side of the coin is maybe in what innovation can we expect? Well, I think the innovation is only what we ask of it. What we should try to make are these systems that can have high-level interactions, that can be spontaneous. Now, is it some AI system that's going to recognize the energy of my input? You know, I don't even dare say emotion, you know, because that you very quickly, you know, it's this sort of slippery slope between what you might want to push the technology to do and some marketing phrase of, you know, make any music with your emotions, that we know would be nearly impossible and not interesting anyway. But somewhere in between, a fluidity with these technological systems to be spontaneously expressive is something, is an innovation that we might hope to expect.
One last thing that sort of like struck me is that you use essentially the AI by doing this mapping process as a sort of like virtual organ builder because there is this like key notion in electronic music, you could say the organ builder and the organ player have been replaced by the performer doing both at the same time, because as you turn the knobs in your oscillator and turn, you know, some parameter in your filter somewhere, you do the same thing as the organ builder would do by sort of like up and down regulating pipes, which they can do once, and then you have registers and that's it. While now you can sort of like change the organ as you play. While what you're doing here in this piece in particular is you sort of like harness the AI to do that configuration, to locate you in the space. Of course, you know the space, your 19-dimensional sort of like granular sort of like repertoire, but actually you use the AI like this, and I think that is a really interesting thing because it goes beyond sort of the aesthetics of Busoni. It goes beyond the quote unquote new aesthetics of Curtis Rhodes with all the granular synthesis. So do we enter a new era? And other than just having like endless Spotify elevator music, do you think that there is a use for AI where literally every textbook from before 2015 we can throw out the door?
No, I don't throw the old textbooks out.
Of course, we never do.
As you can see, I'm interested in digging into the history, and with Pasquinelli, we see the interesting social history of the AI. And in texts that I'm writing, I still go back to Helmholtz and the physiology of the ear. And in fact, these are the things that perhaps in our fascination with the future are getting lost. Now, is it a new aesthetic? Well, there will be an evolving aesthetic. There has been a kind of a machine modernism that will have its limits. The 20th century was a very interesting time, but it does come out of certain human social history, not least of which includes a kind of, I only refer to it as a behavioralist approach, but if you think about eugenics, and measuring human capacity, and differentiating races and cultures based on measurements of the skull and these things. Of course, we are not doing that, but some of the systems that we have built and some of the paradigms of scientific development and engineering have come out of those eras, and we're still using some of those technologies. And that's why I think historical awareness is super important. That being said, I'm using the multi-layer perceptron. I'm using Curtis Rhodes granular cloud generators in my piece, re-implemented, for my piece in Brussels last year with the trio. So technology is not neutral. At the same time, it is flexible, and despite the context within which it's created, the new contexts of use, I think, can be certainly interesting. Yeah.
Excellent. There is there's a neat fact about Helmholtz's Tonempfindungen, which is in the foreword, he mentions that he was able to build a synthesizer not because of his usual funding, which would be the Prussian emperor, but due to the Bavarian king, because nobody in the established science system would actually fund such a crazy thing, such as a synthesizer. So he asks the arch rival, who actually a couple of years later has a war against him, to actually fund this thing. And I find that quite interesting, because this kind of research actually suffers from the problem that it is sort of caught between art and science, right? Yes. So there's you can get arts funding, you can get science funding, sometimes you can get other cultural funding or humanities funding or whatever. So one of the interesting questions for like young scholars probably is how can this be sort of like, how do you solve the problem that some of the more crazy things are not mainstream wherever you will go to get funding, for example? Because, I don't know, the European Research Council has one person like you among 12 evaluators. So how do you deal with that?
Well, does the ERC have one like me? Actually, I would say no. The music and this kind of music has been really quite successful in ERC funding. I've had my project, but so has Alexandre Tremblay and his Flucoma project, Francois Pachet and Flow Machines. Georgina Bourne, as a cultural anthropologist of music, has studied digital music, has a second project now studying AI and music. And although that's a kind of scholarly research, we know her to be a cellist who played in the rock in opposition movement, as a cellist, And so, in fact,
Thor Magnusson and Andrew McPherson.
And Andrew McPherson. So in fact, music is really kind of an interesting space for this, because it has always been technical and cultural. And the example you give, Max, of sponsorship and playing new instruments for emperors and so forth. Yes, there's a rich history of this. I mean, the theremin would not have existed, if the theremin himself had not been posted as a spy and had been an unsuccessful spy and nearly got fired. He paid for this by then losing, being brought back to Russia and to the Soviet Union and having to toil in other sort of military systems, but between that and I'm writing a text on the history of some of these things in my upcoming book, and so the historical aspect and the question of sponsorship is very much at the fore of my thinking now. The book won't come out for about 9 months or more, but it's been announced, so I'll put the link in it for it here. It's called Body Music. Let me see if I can. And so there is a chapter on AI where I really engage with Matteo Pasquinelli's book. There is a chapter on instruments where I engage with Thor Magnusson, and also this history, this question of the social context, or Napoleon, seeing some of the early interesting works in this area and so forth. So taking this sort of historical materialist view in this field that we're in. So hopefully, if you can all be patient while I finish, I'm going to deliver the manuscript to the publisher in 2 months' time, and then we've got to go into production. The fact that it's been announced puts on the pressure, but it'll be there in early 2026.
Super. We have time for one more question from the audience, if somebody likes to. Then I will ask the last question. So one thing that struck me is that's one of the reasons why I brought up modular synthesis is the perceptron itself is sort of a module, and very much like we imagine the brain also. And actually it indeed exists as a synthesis module. There have also been people like David Cope who sort of built a neural network synthesizer on a neural network chip. So there's these kind of things where, obviously one can sort of focus on that thing, not as a sort of tool within the instrumentation of a piece, but sort of as the sort of instrument itself. Yeah. And is that some temptation you have sometimes where you say, oh, I would really like to sort of more organically integrate this thing, which right now does a particular for example, how about the neural network itself producing sound? So this distinction of control voltage and sound signal sort of goes away as it has in some modular synthesis.
Yeah, absolutely. I mean, that's why I'm interested in working directly with signal and not with this musical representation of the symbol. If there's this really rapidly developing area of what we call neural synthesis, people are definitely working in this area. But does that make it more organic? Does that make it the instrument? Maybe, but maybe not. So I think the organism comes with our relationships, our interactions with the system, and the definition of the instrument. Anyway, today we're no longer making a resonating cavity with wood and a vibrating string as one object. We're making extended systems that can be considered instrumental systems. So in all this, and somehow to finish by also coming back to your question of the organ builder and the organist, and then this current question of the organic system and the instrument. What we have today is the possibility that these former roles can be blurred, right? And you have people claiming to be multiple things in their email signatures, and we are asked to be more than one thing. We can be the instrument builder and the composer and the performer, and maybe I claim to be, but there's a certain responsibility in taking on these roles, and sometimes it's convenient, not convenient, but sometimes it's essential to remember why these old roles exist, and why the tasks may have been delegated or compartmentalized. But regardless, I think we have questions of instrumentality, questions of human-computer interaction, human-technology interaction that are no longer just simple interactions, but what are called human-computer partnerships, when the post-humanist discourse is not called interaction anymore, but intra-action. And it's not just a case of whether the neural network synthesizes the sound and is therefore organic. It is to think about what are the systems that we build, whether they can be localized in one algorithm or is a assemblage of techniques, the intra-actions and the entanglements that we create, and the expressive spontaneity that I would certainly look for in those configurations and systems and situations.
Thank you very much. This was an exciting 2 hours. You certainly widened my horizon and I think of the audience. And we're looking forward to next week, where we have Jorge Caballero from Barcelona, and he will talk about AI in documentary cinema. And basically, we're continuing our ride on the spectrum of application areas. So we had some linguistics, we have music today, and we have cinema next week, which rides on a bunch of talks which were more technical about the functionality of AI and physics. And so thank you very much, Atau. This was amazing. Thank you.
Thank you. Yeah, thank you. And I look forward to seeing the recording. And if anyone has questions, yeah, please